Everyone. Good morning, respected authors and invited guests. Welcome to the technical session 11D. Myself, Gayatri Burguda, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. And there's another request to all the participants that you all stay connected with us till the closing remarks. If you have any kind of query or update, then you can write it to me in the chat box. And just before we start the session, I would like to introduce you all to the chair for this session. Dr. Stephen Ricardo Gomez Torres is a professor in the Department of Computer Science at the University of the Armed Forces, ESPE, Quito, Ecuador. With approximately 25 years of experience in academia and industry, he specializes in artificial intelligence and mobile computing. His research focuses on context-aware systems and smart city technologies, contributing to intelligent, adaptive, and urban digital solutions. Sir, would you like to address the participants?
Thank you very much. Good morning to everyone. It's my pleasure to welcome you to ICTS conference in Bangkok. We are honored to have you here and look forward to insightful discussions and meaningful exchanges through the event. Thank you for joining us, and I wish you a productive conference. Welcome to ICTS Bangkok.
Thank you so much, sir, for your motivational words. Now, I'd like to introduce you all to our second chair, Dr. Nitin Sakre. He is an assistant professor in the Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune, with over 9 years of academic experience. He has published more than 30 research articles in reputed journals and authored over 100 books. His research interests include data science, machine learning, computer networking, and the Internet of Things. Sir, would you like to address the participants?
Yeah, sure. Thank you, Gayatri, for the kind introduction. So I wish very all the best to all the authors who are presenting for this conference, and we would like to hear a lot of the research work that have been done by different authors. And again, wishing all the best to everyone. We are eager to hear all of them. Yeah.
Thank you so much, sir, for your motivational words. So, with that, I would like to finally start our session. I would like to invite the first presenter for this session, Sankyo Jeong Sir, to present his paper titled A GPU to NPU Transition Framework for Energy Efficient Deployment of Medical Vision Models. Sir, you may start presenting now.
Hi, my name is Sungyo Jung.
Yes, sir, you can start presenting.
잠깐만. 이거 공유 어떻게 해? Good morning. Good afternoon. My name is Sungyo Jung.
You can start, please.
My
Mr.
name is
Yeah.
선교정 from Dankook University. Today I will present our work on a GPU to MPU trans, transition framework for energy efficient deployment of medical vision models. Validate through a case study on the Atom MPU platform. Most medical AI models are trained and validated in GPU environments. However, real-world deployment often occurs on MPUs, which are inference-oriented and energy efficient. The problem is that even the same trained model, when executed on heterogeneous hardware, may produce numerically divergent output. This deployment gap motivated our research. Our research question is straightforward. Can we preserve functional equivalence when transitioning from GPU to MPU without retraining or modify the model architecture? Only the execution environment changes. We structured the transition as a systematic framework. First, we fix the GPU reference model. Second, we ensure unified pre-processing alignments. Third, we convert the inference graph into an intermediate representation. Fourth, we manage operator compatibility. Fifth, we perform NPU compilation. Finally, we validated functional equivalence. We used a ResNet 50-based medical image classification model trained on the patch chameleon dataset. We evaluated 1,000 test samples. Input size and pre-processing were identical across environments. The deployment platform was the Atom MPU. Out of 1,000 samples, 991 produced identical class prediction between GPU and MPU environments. This corresponds to 99.1% agreement. Importantly, evaluation was performed at the patch level. The core objective is not accuracy improvement, but presentation of inference behavior. Why was the agreement not 100%? The GPU operates with 80-32 full precision. The MPU runtime may internally use mixed precision for efficiency. This can introduce minor new medical differences, especially for samples located near decision boundaries. We also observed a reduction in average inference latency in the MPU environment. However, latency comparison is supplementary. The core metric of the study is functional equivalence. There were 9 mismatched samples corresponding to 0.9%. These discrepancies occurred near classification decision boundaries. Input tensors were fixed to plot 32 prior to compilation. Mixed precision operations inside the MPU runtime likely contributed to small numerical variations. Importantly, no model parameters were modified. To ensure reproducibility, the reference model was explicitly fixed. The SHA-256 hash of the model file was documented. The pre-processing pipeline was identical across environments. Thus, execution backend remained the only variable. We reframed the deployment transition as a research problem using functional equivalence as the core metric. We demonstrated 99.1% agreement on the Atom MPU platform. This shows that reliable GPU to MPU transition is feasible without retraining. Reliable deployment requires system-level validation. Thank you.
Thank you so much, sir, for your presentation. Do we have any questions?
Yes, please, I have one question. As you know, in this type of solutions, one of the problems is overfitting. How did you address overfitting and ensure generalization, please? Did you hear me,
Sorry.
sir? Yes, I'm talking about generalization. How do you assure generalization in your system considering overfitting? Did you understand my question? Or should I change? Hello?
Yes.
Okay. Your model could be integrated into clinical practice? Yes or no?
Mm. Or next.
Okay.
I think
Maybe
Jeong sir is facing some technical issues, so he's not being able to
yes.
understand the question.
Yeah. Yeah.
Yeah, I think we can move on to our next presenter then. Thank you, Jeong
Yeah.
sir, for your presentation.
Oh, thank you.
Yes, I would now like to call upon our next presenter, Franklin Rivas, sir, to present his paper titled AI Applications in Environmental Management, a Scoping Review. Sir, you may start presenting now.
Yes, here I am. Can you hear me well? All right. Could you please let me know if you can see well my screen? Let me please share
Uh,
my
yes,
full
sir, your screen
screen.
is visible. You may start presenting now.
All right. Thank you so much. Well, thanks a lot. It's really a pleasure for me being in such an interesting conference and this session. By the way, good morning to everyone. Good afternoon, good night, according to where are you going to be located. In my case, I'm right now in Arlington, Texas, in the United States. So here is almost 1 o'clock in the morning. I suppose that will be maybe the same time for Dr. Esteban. If he's in Ecuador, should be also 1 o'clock in the morning there. So here it is quite late. Okay, today I'm going to be sharing with you our work that was done with a cooperation between one Ecuadorian university that's going to be the Pontificia Universidad Católica del Ecuador in Ibarra, and also with the Computer Science Engineering Department of the University of Texas at Arlington, and currently now, and also we have been working with the Environmental Agency of Abu Dhabi in those cases. So here are the teams that we were working in here, both of them, the first one, I belong to the first and the last organizations, Tam belongs to the last one, and Jorge and Aisha, they belong to the environmental agencies here. So, well, we try to focus and about to try to find what is the most relevant information we can find nowadays about what is going to be the use of artificial intelligence in environmental management in here. Of course, we want to see what is going to be the relevance of it. Nowadays, certainly artificial intelligence is the most relevant domain of science or whatever, how we can define it is. The term even it was defined as the most relevant term in the couple of years ago because it's doing is going to be around in all our life here nowadays. And it has a lot of really very good improvements in any kind of quality of processing information for trying to make or to build new solutions, for trying to solve many of the things. By the way, some of the questions that maybe was asked by Dr. Esteban before, when you try just to focus on the right solution for the problem, you want just not only to learn, you want just to generalize, have the generalization capability for trying to make these things. So certainly that's going to be something that has a lot of capabilities. Of course, on the other hand, we are now facing a lot of different climatic changes all around the world, and that has a very, very a big challenge for all of us to try to we can move in the same way that we are having these changes, and we're going to be trying to do this kind of thing. So certainly, artificial intelligence will be something important to take care about that. By the way, some of the typical methods that has been used for working in environmental systems, it has going to be just maybe slow. Some of them are going to be a little bit inefficient because, for example, when you want to just focus on forecasting, even the United Nations has just a complete group that is going to be dedicated to this kind of thing. So certainly that's going to be doing that. And artificial intelligence has a lot of the very great capabilities. So we think it could be quite interesting to know what's going on currently, according to the most recent research that has been published, and also to try to see where is going to be maybe some kind of domain that will be really interesting to develop and to create and to design some new application. So that was our idea here to try to find this kind of system. So we try to take a look to the different publication that was made in the last 5 years from 2020 until 2025. And we try to just group them according to some kind of major environment sectors in those cases. And according to that, we were going to be seeing what is going to be just the right opportunity, what's going on nowadays, and what was going maybe to be coming in the future about this kind of things here. So, well, certainly, well, because of the time, I'm not going to be talking about much about what is going to be just a procedure, but any kind of systematic review that you want to do in there, there is a very different methodologies. Maybe you're going to be using Prisma or some other of the methodology. You have a lot of different things. You need to find what are going to be the databases that you're going to be considering for it. For example, we just take the major databases like Scopus, Web of Science, IEEE, ACM, and Science Direct, because it certainly are going to be there. And we try to just cover things that are related to computer science engineering and some kind of environmental management in those cases. Of course, according to this, well, we make one of the different things. You need just to select which are going to be the queries that you're going to be using for finding the information. And well, we made all that procedure. And well, we found a lot of different information about that. And that's the interesting thing, is that we see that every year we're increasing a lot from at the beginning of this and 2020 and 2025, we have maybe some cases more than 7 times the number of publication that was being doing related to these areas, to the environmental areas. That's maybe is something very important and very relevant, because that means that the researchers in the world, people who are working in this, are really focusing on something that is relevant for all ourselves and the welfare of all of us in those cases. So after taking a look to this, we decided just to find which was maybe the 5 most relevant areas according to the publication we find there. And certainly there was dedicated to these topics, something related to the renewable energy here, water management, agriculture, waste management and circular economy, and environmental health and public safety. Certainly that was maybe, if we want to group the different things, the different topics, the different elements that have we found in there, we can group in these 5 elements in here. So, well, just for giving just a very brief information about each of them, the most relevant thing that is being published in the last 5 years about that, for example, the use of artificial intelligence in renewable energy certainly has been used a lot for predicting or for forecasting the energy generation. I think it's quite important, because that's something we will need to do it, because we need to see what the requirements of energy anywhere and every time is going to be increasing a lot of it. Also for fault detection and isolation systems, and try to find some kind of problems, inefficiencies that we can find in those systems in there. By the way, the third one was quite interesting, because it's certainly the use of new technologies as artificial intelligence, Internet of Things, IoT, and how they're going to be using for really trying to make some kind of optimization techniques for trying to really do about the grids we're going to be having there. And then also it has been used this for trying to support plannings. So making this about environmental uncertainty, that's something that is always going to be present about in this kind of system about that. Then, when we moved to the second area we found there, that was water management, well, it has been great and well, very nice application about the detection of leaks. Certainly, that's quite important, because we have a lot of different leaks, and we need to maybe try to avoid this kind of thing, because losing water is not any way at any kind of good solution, because we needed it and more to try to get as most of it and try to take it to the most apart places for giving water for everyone, and try to find even the use of big data for trying to just find full people data sets, for trying to collect information from different places about that, and also for making something about decision making. That's quite important, because we're going to be using in different levels, from the operational level until even the management level, the strategy level. And that means that we are told really, we can see that nowadays it has been working in all the different levels of hierarchy, and the use of, maybe if you want to see the automation, pyramid or anything, it has been doing works in all this area, and that's going to be just quite important about this. Well, we don't have the time, we need to move forward very fast. Then we focus on agriculture. There are wonderful nowadays application of this, and every day it's collecting things. Now it includes also robotics, more than just artificial intelligence, and try now just to use it for trying to improve it, for trying to prepare the places, for putting there just the food that you're going to be collecting in those cases, for trying to see and to optimize something very important, how you want to make the optimization of the irrigation, because we don't want to spend more water than we really require that. We want to use the less as we needed, the pesticide, and so on. So that kind of thing is being used with artificial intelligence for making models for doing these kind of things, and maybe also to try to really try to have climate resilient farming decision. That's quite important again, because we have now, with all these changes that I mentioned at the beginning, we're facing nowadays. We need to try to create systems that could be adapted to the different changes we're going to be having in there. And so it's important to have even the right devices, IoT, different other devices that we can have in there, artificial intelligence, cloud computing, for trying to make these kind of things in those cases about that.
Excuse me,
Certainly,
sir.
the other,
You have
sorry?
1 more minute to conclude your presentation.
All right. Yes. Okay. Well, about water management, we have also seen some kind of wonderful application. Also, using robotic computer vision has been quite important about that. And finally, in the environmental health, we see that it's something that is going to be focusing really on the human being. We're going to be seeing that it has been using a lot of different new technologies for trying to use C. So, well, it was really C, and there was some kind of other elements that we found that is being transversal to many of all these different areas about that. Certainly, there are still some new challenges. We try to see what is going to be the newest thing in here, and we will see that maybe some of the things is using now transformer, meta learning models, IoT, and also we can be seeing that it's going to be appearing a lot that will be part of the future, maybe quantum computer and quantum artificial intelligence. Of course, there are some challenges about ethical risk of it, about biases, about lack of transparency, operational risk, and so on. And now, well, of course, by itself, artificial intelligence is something that is going to be spending a lot of different energy, a lot of it is creating emission, has a lot of cost, and we need to deal with that to try to use some kind of more sustainable artificial intelligence. Something that is coming in the future, certainly the use of agentic. There are not so much publication nowadays about that, but that's something that is maybe the most well training here. And again, also, as I mentioned, quantum computer about these things. So certainly it's very good news to know that there are a lot of people working on this, and then we are going to be having a very nice future about the use of artificial intelligence related to the environmental activities all around the world. And well, that was something maybe that we wanted to share with you. Thank you so much again for this invitation for presenting this job working here. Well, I will be open to any kind of questions that you may have.
Yes, thank you very much for your presentation, Franklin. Yes, indeed, I am here in Ecuador, and it's very pleasure for us to meet people from Ecuador in this principal event. What is the main gap that you have identified in your survey? In your study,
Well,
what's the main gap that you have identified?
Well, there are so many things, because now we found that it's going to be quite an interesting opportunity for dealing with it. So because that's something that is not working a lot nowadays, as I mentioned, certainly it's going to be using of the agents. Certainly, generative AI is one part of artificial intelligence that we need to be very careful with the use of it. Because as this is being defined by itself, when you ask any kind of LLMs nowadays to define themselves, they create things. So they can be doing things that maybe could not be so right. So you can use it, and it's going to be done here in the United States. For example, now we have a lot of company that is making as a policy that they're not going to be allowed in the use of generative AI until they create some kind of protocols or way of doing this. But the agentic activity is going to be something that is going on there. We're working now on some other projects together with Ecuador, with Emirates, and even in Spain together, trying to use a quantum artificial intelligence for about that, because that's something we need to deal a lot with it. There are great opportunities. We need to have very fast decisions so many times. We need to have very accurate models. Well, now we see in a couple of hours ago that we have received now these people that was in their Artemis 2 ship on the space. And well, imagine all the technology you need to create a trajectory for going there, for moving one spaceship like this. and then all the kind of affectation in environmental. We need to be very fast nowadays. We need to have fast responses. We need to have great models, and then there is certainly something that we need still to do it. And certainly the use of IoT and cloud computing should be included a lot also in this kind of technology. I think that's maybe the biggest event. And also certainly it's a very big pleasure. And I hope we can keep in touch later, Dr. Esteban. It will be more than a pleasure.
Thank you. Thank you very much for your reply.
Thanks.
No more questions for my side.
Thanks a lot.
Thank you so much, sir, for your presentation. Now I'd like to call upon our next presenter, Mallika Acharya ma'am, to present her paper titled Cross-Domain Point of Interest Recommendation for Tourism, a Reinforcement Learning Approach. Ma'am, you may start presenting now.
Good morning, ma'am. Am I audible, first of all?
Yes, ma'am, you're audible.
Okay. So, ma'am, I'm starting with my paper. I'm actually sharing the screen. So, ma'am, is it visible?
Yes, ma'am, your screen is visible. You can start now.
So, good morning, everyone. I'm Dr. Mallika Acharya, and this work has been done in collaboration with my colleague, that is Dr. Uncle Chen. We are the assistant professor at the LNMIT Institute. So, let's begin with the topic. The topic is basically focusing on the cross-domain tourism. In this, basically, if you see over here, the business travel, tourism, or even remote work aspects have given to users priority to move to the remote locations and recommendations in such cases often fail. The reason being that there is unfamiliarity of the algorithm. Second case, if we are moving on to the home city of the user, we see that the user visits very small fraction of the tours. As a result, again, the data and the preferences of the user is limited. When the data is limited, again, cross-domain approaches become generalized and the transfer of knowledge from sense to domain is very less. In the second, again, if we move ahead, then we can see that when a user is moving to another location, we often actually face the problem of preference, which is the same, but their predictions or rankings change from their sense to home and to their private city. The models that we are proposing, they should adapt to the recommendations, and also the personalization of the recommendations should be there. So, in this case, the problem that amplifies is tourist usage, which is generally because in such cases, when the user is moving from a newer city, we don't get that much amount of data for the user, and their preferences is also not locked in the model. So, as a result, we require to develop different cross-domain models. In this case, traditional methods they often fail because they require overlap between the user and the POI data, which is very minimal in the case of cross-domain. Secondly, we have to balance both the exploration and the exploration preferences. That is, we have to recommend both novel recommendations, as well as we have to consider what is the user's likings or the preferences. And further, it is also very hard to adjust to one's personalization when the one particular POI that is very much popular is being recommended. So, our model over here also addresses another problem, which is geometrical misalignment. As I said, when a user is moving from one domain to another, we often face the problem that the embeddings that are made by the traditional method, they are misaligned. If they are misaligned, they are not going to generalize that what is the current trend between the source and the target city. For example, if I'm saying that a person is moving from New York to Tokyo, then definitely there will be a vast gap in the embedding. Many of the models that are proposed to be do not take into account which does geometric misalignment. So we propose this as our model. Over here, we have done certain, background studies, which I'm going to skip because there is a limitations of our. Let's move ahead with the major contributions of our study. The major contribution includes developing a geometrical aware recommendation system, which personalizes the preferences based on the cross-domain learning, multi-bandwidth decision making, and domain invariant learning. Secondly, we address both the presence of unexplored POIs and that without requiring any overlap and similarity weighted loss of initial assessments. And finally, the PCTS architecture, that is actually a three-phase architecture that we are going to discuss in further students. So let's move ahead with the first phase. First phase is basically reference transfer from the source city. In this, you can see that at first the data is there, and also in addition to the data which is there, we give particular context to the user, that is stock. This stock context is nothing but in our case is the time at which we are asking the model to recommend the information. Then we utilize a shared encoder which converts these features into embeddings, and it is basically the same encoder for both the domains. Finally, this model predicts the probabilities for whether a user has visited the POI in source domain and whether there is a probability of visiting the same type of POI in target domain. And we utilize a GRF, which is actually a gradient reversal in adversarial learning, so that we can understand the domain invariancy for the different in source and the target domains. These are the equations that for the first phase that you can see. And moving on to the next phase, which is geometrical domain alignment, or over here we utilize Computer's transformation. So for this, our first step is to identify certain anchor pairs. These anchor pairs are nothing but they are the reference points for which the alignment needs to be done. These anchor pair is designed based on the similarities and popularity. And after we have identified the anchor pairs and the references based on these, we utilize Computer's transformation. Transformation basically helps us to learn the rotation, inaccurate scaling feature, and the translation vector. Based on that, again, our major objective is still the same. That is, we need to minimize the distance between the transform learning from the source and the target, based on all the anchor points. Try these transformations that have been learned, and then finally, we develop meaningful, as domain recommendation. So you can see over here, this is my second phase that I have applied. And over here in the weight calculation, you can see I'm combining both the similarity as well as the popularity aspect. Then over here I've applied the optimization based on propulsors and have learned the parameters of repeatation, scale, and translation. And then finally a similarity computation has been done for both the embeddings that we have calculated earlier. In the third phase, which is the last phase in this model, we are using the adaptive Thompson sampling for sleeping bandit problem. So basically, in a sleeping bandit problem, we have actually identified all the start user scenario. And over here, to address that, what we have done that rather than utilizing the same thoughts each time, we are actually using the concept of data prior initialization. And in this, we are using adaptive Thompson sampling. So over there, the scoring function is combining both the probability of user POI similarity and the exploration factor. So in order to show you can see over here, these are my equations that arm selection has been done based on the selection score. And that selection score actually utilizes both the Thompson sampling as well as the weighted exploration factor, that is. And based on that, I've identified the outcome, that is the balance between exploration and exploitation method. And before the start scenario is here. Experimentation for this particular model has been done on seven patients, and each of them have been extracted from modeling Iguana and Photosphere dataset. Both of them were publicly available. You can see the different 7 zones that we have: California, Washington, Ohio, Tokyo, Azure, Puerto, and home. And over here, the data has been split into training, validation, and testing set, that is 80, 10, and 10. The baselines of this model are the UCB, NPS, and Ancelotti. Both of the UCB and NPS, these are basically the state-of-art approaches. Now, the evaluation matrices that have been utilized are sleeping bandit recall, novelty, precision, and MDCG, and the domain alignment score. So you can see the results for precision for the different domains of California, Washington, California, Ohio, and Tokyo and AF. Over here, our matrix in dense PCTS is performing better than the other state-of-art approaches. And we goes on for MDCG comparisons with the other approaches. These are my results for this sleeping bandit recall and novelty on different regions. You can see our model when compared to the state-of-art UCB and NPS, they are the best. Our model is the best. I'm sorry. Next, this is my domain alignment score based on the different epochs, different
Ma'am, you have one more
conditions.
minute left to conclude.
Yes, ma'am, I'm approaching to that only. Okay. So you can see over here, the DAS, that is the domain alignment state with different epochs and the exploration rates. And you can see we have achieved a plateau after a certain time. So I can see that initially my model was learning. That means it was exploring. And after some time, when the transfer of the knowledge different state, now it has achieved a plateau. This is for different cross-domain areas. Similarly, in PCA visualization of my model, you can see over here the embeddings have initially you can see they are quite distorted, and finally, and as the optimal DAS of 0.97 to 95 when they were achieved, you can see that they are now aligned towards each other. Concluding on the geometrically aware cross-domain recommendation that we have developed is actually handling both the preference shift and providing us with the best exploration and exploitation training. It handles only star problem for sleeping bandit and similarity-based trials that we have already discussed. And then the dynamic exploration and exploitation that we have talked about is basically giving us a better alignment, a domain alignment skill. And I can say that my model is giving me good accuracy as well as the results. These are the references that I have used, and that's all. Over to you, ma'am.
Thank you so much, ma'am, for your presentation. Do we have any questions?
I have one question, Liz. Um,
Ma'am, you're
how
not
do you
audible. Yes,
how do you select
ma'am, you're audible.
the best granularity level for your data sets?
Sir, basic granularity level 4. Sir, please complete the
Talking
question.
about talking about the granularity of the data sets, how do you choose the best granularity if it's possible in your system?
So the granularity in our case is basically the alignment so that is based on units and it has been done as per the number of units you see over here. The granularity level is threshold. So it's basically image transfer is fixed. And one of the practical limitations while doing this that we have seen is that since the data is very sparse in case of smaller regions, like in case of Japan, it was very sparse. So that is one of the practical limitations that we faced.
Okay, thank you
Yes.
very much.
Thank you, sir. Any other questions?
Thank you, ma'am, for your presentation. I guess there are no more questions. Now, I would like to call upon our next presenter, Tan Nok Thien Sir, to present his paper titled DEFCM, Effective Customer Segmentation via Deep Embedded Fuzzy C-Means. Sir, you may start presenting now.
Yeah, I'm here. Can you hear me?
Yes, you're audible.
Yeah, I will share my slide. Uh, yeah, hello everyone, and I'm Trần Ngọc Thiện from Hanoi University of Industry, and today I'm present about the FCM, effective customer segmentation via deep embedding fuzzy CMIN. This research addressed how to effective segment customer for personalized marketing. Customer segmentation is fundamental to maximizing customer lifetime value through personality marketing. We use LRFM model, length, recency, frequency, monetary, a compact feature set for observing customer habit. The problem. Therefore, feature interact in a complete non-linear pattern Standard algorithms like k-mean and fuzzy-mean use Euclid distance, which cannot control hidden structure. Example, a customer with high monetary value may be a maybe a VIP if their recency is good, but the same value indicate the chance risk if recency is poor. Current deep clustering method face uh, three challenges. First, rigid boundary duration hard clustering ignore uh, natural behavior overlap. Customer don't certainly switch segment. They transition gradually. Second, no great membership without soft score. We cannot differentiate between core member who strongly belong to a segment. Reverse transitioning customer. Third, in random starting point lead to uh, convergent, making result unstable. To address their limitation, we propose DEFCM, deep embedding fuzzy CMIN, forming contribute a, a joy optimization framework that train an autoencoder alongside fuzzy constraint in the latent space. Boundary away assignment that classify customer as core or transition case, empirical validation across three datasets showing a significant improvement in fuzzy metric and a practical highlight for changing stability and fuzzier conflict. Let me explain the DFCM architecture. We will input X pass through an encoder producing a 10-dimension embedding edge, a fuzzy layer, then compute fuzzy member U and update cluster center V. The decoder reconstruct it had from the embedding, and the key innovation is our joint loss function reconstruction loss preserving important information why fuzzy loss create compact cluster alpha balance reconstruction beta balance fuzzy clustering. Mm, a key advantage of DEFCM is the membership vector, providing great assignment. We define two types of customer. Firstly, core customer, maximum member below 0.7 are profitable people segment with clear behavior pattern and transition customer, the other member, so behavior shift. This customer need intervention before they exit. Unlike DEC and IDEC, we use proxy assignment, our membership value, and predict our output optimized by the FCM objective. The FCM training has three phases. For the setup phase, we pre-train the autoencoder on reconstruction loss, and then we run k-mean on their initial embedding to set realistic starting clustering center and alternating routing. Each epoch, we methodically compute membership and center, then feed them and run SGD on the network. warm-up phase beta intrude gradually from 0 to its target over 30 epochs. This let the network learn accurate data representation before enforcing uh, clustering boundary. We evaluate on three datasets for the e-commerce from UCI online retail with LRFM feature and country and overload. We compare again S baselines in the K-mean, FCM, PFCM, CFCM, DB scan, DEC, IDEC, and DEK mean. Magic will sign off and CF, where higher is better, and DBI, HBI, and FHP, where lower is better. Looking at our result across all data set, we can see with e-commerce, the DEK mean achieved at high risk, shift how, but the FCM dominate in a fuzzy magic, if for time better. With country data set, we can see it the 3.4 time better. And with Abalone, DEFCM have the best score with minimal variant. Wilkerson siren test confirm their different are statistically significant with p-value less than 0.001.
Excuse me, sir, you have 1 more minute left to conclude.
Okay. For practical, the fuzzier M should be kept in the round 1.3 or 2.34 stable performance as M1. The EFCM degrowing rate to hard clustering. And to cover, the FCM combine deep presentation learning with fuzzy clustering it lead in fuzzy magic while maintaining competitive separation. Trading set 3 to 5% how 6 how for superior. Boundary handling the fuzzy membership enable identification of transition customer, providing action label inside beyond hard label feature work, attention mission for interpretability, automatic cluster determination, and enable technical coming, DEK mean and DES C mean. Video overview about my research. Thanks for your listening.
Thank you so much, sir,
Thank you.
for your presentation. Do we have any questions?
Yes, this is the question. How did you validate the reliability of your results? We're talking about the precision of 97%. So how did you validate your results?
Okay, thank you so much, sir, for your presentation. Now, I'd like to call upon our next presenter, Neha Agrawal ma'am, to present her paper titled Enhanced Object Detection Using Meta-Heuristic Feature Selection and Deep Learning. Ma'am, you may start presenting. I assume ma'am is absent, so we can move on to our next presenter, Muhammad Al-Fatah Rashid Hamouda sir, to present his paper titled Interpreting Digital Brand Narratives, a Roland Barthes semiotic approach to the HMNS Untitled Humans Instagram Reels campaign. Sir, you may start presenting now.
Okay. Good afternoon, everyone. My name is Muhammad Al-Fatah Rashid. You may call me Rashid. I am currently a master degree student at Binus University, Indonesia. Today, I would like to present my research entitled Interpreting Digital Brand Narratives, a Roland Barthes Semiotic Approach to the HMNS Untitled Humans Instagram Reels Campaign. Okay. This study aims to analyze how meaning is constructed in digital brand campaigns using the semiotic approach of Roland Barthes. In the context of digital marketing, storytelling has become increasingly important as brands try to create emotional connections with their audiences. This research focuses on how visual, audio, and textual elements in Instagram Reels interact to layered meanings. To produce layered meanings. Social media platforms, especially Instagram, have become an integral part of modern communication and marketing strategies. This campaign reflects a shift in marketing where brands are no longer just selling products, but also building emotional narratives and identities. From a theoretical perspective, semiotics helps us understand how meaning is created through signs, image, and text. Therefore, this study explores how storytelling in digital campaigns can create deeper engagement with audience. Okay. Okay, this study uses a qualitative descriptive approach to explore meanings in social and cultural contexts. The research framework is based on Roland Barthes semiotics, focusing on signs, symbols, and storytelling. The data was collected from Instagram Reels on the official HMNS account, especially from the Untitled Humans campaign. Data collection was conducted through observation and documentation in a natural social media environment. The method is the analysis is based on three levels of meaning proposed by Roland Barthes. The first is denotation, which is reverse to the literal meaning. Second, connotation, which is refers to emotional and symbolic meanings. The third is myth, which represents a broader cultural or ideological message. The results shows that the campaign used visual storytelling rather than direct product promotion. It emphasizes themes such as identity, emotions, and social values. The content presents everyday life's narratives, the diverse characters, and self-expression. Overall, these campaigns constructs meaning through symbolic elements rather than explicit messages. The results, the first reels presents natural elements such as waterfalls, leaves, and sunlight. At the denotation levels, there are simply natural visual. At the connotation level, they represent freedom, balance, and self-awareness. And at the mid level, identity is portrayed as natural and fluid, and perfume becomes a symbol of authenticity and self-expression. The second reels shows simple daily activities like cycling and holding hands. Uh, in denotative, these are very actions, and in connotatively, they reflect intimacy, connection, and the meaning of life. At the mid level, the campaign suggests that meaningful life comes from simple emotional expressions. Reels 3 shows uh, social interactions and emotional moments. In denotation, social interaction and activities, connotation, nostalgia, emotion, and closeness. And in the mid level, fragrance is associated with memory and emotional expression. The for the four reels is the fourth reels is present social activities such as concert and selfies. The denotative uh, means these are collective experience. In connotatively, they represent joy, freedom, and identity. At the mid-level, identity is formed through social connection and perfume as a symbolize both self-expression. Next, we move to the discussion part. The discussion shows that each reels represents a different aspect of humans' experience, and nature reflects authenticity and self-awareness. Daily life highlights emotional connections, and emotional scenes represent memory and introspection. And social scenes emphasize identity and expression. Overall, the campaign integrates multiple elements to create a deep and meaningful narrative. The conclusion, the humans or HMNS with the product Untitled Humans campaign goes beyond traditional advertising. At the denotative level, it presents authentic everyday life visuals. At the connotative level, it gives emotions and personal memory. At the mid level, perfume becomes a symbol of identity and emotional closeness. The study highlights a shift in digital marketing from product-based communication to emotionally driven storytelling. Therefore, this campaign is not only about perfume, but also about identity, emotion, and human values. Thank you for your attention. I will be happy to answer any question.
Thank you so much for your presentation. Sir, do we have any questions?
Mm,
No, Gayatri,
Yes,
no
I
question.
have.
Yeah.
Yes, I have one question. What challenges did you face when integrating IoT and AR in real time?
Muhammad Al Fatah, sir, could you hear the question?
Hello, I cannot hear clearly. I'm sorry.
Okay, I repeat. What
Yeah.
challenges did you face when integrating IoT and AR in real time?
Okay, I will answer this question. One of the main challenge in this research was interpreting subjective meanings from visual and audio elements. Like since semiotic analysis relies on interpretation, there is always a risk of bias. To address this, I used a systematic framework based on Roland Barthes' theory, focusing on denotation, connotation, and myth to ensure consistency in analysis. Another challenge uh, was selecting representative data from Instagram Reels, as the content is diverse and very dynamic. Like I selected data based on engagement, narratives, richness, and symbolic elements. Despite This challenge, this approach allowed me to gain a deeper understanding of how meaning is constructed in digital storytelling. Thank you.
Thank you.
Thank you so much, sir, for your presentation. Now I'd like to call upon our next presenter, Pankaj Chandri, sir, to present his paper titled Fishing in the Era of Generative Artificial Intelligence, a systematic survey of attack models, detection strategies, and explainability. Sir, you may start presenting. I assume sir is absent, so we can move on to our next presenter, Sabit Rahman sir, to present his paper titled Potholes, Cracks, and Open Manholes Detection Using CBAM YOLO V8 and GPS Coordinate Extraction via OCR for Location Mapping and Automated Alerts. So you may start presenting now. Sir, you can start your screen and start presenting. I think sir is facing some technical issues. Okay, in that case, we can move on to our next presenter. Sabit sir, you're not audible. Sorry, sir, we can't hear you. Can you please check your if you have any technical issues and just get back to us with that. Meanwhile, we'd like to move to our next presenter, Dao Thi Hyung ma'am, to present her paper titled User Classification in E-commerce Platforms, a machine learning based approach. Ma'am, you may start presenting now.
Good afternoon, esteemed scientists and expert. Thank you for being here today. My name is Đào Thu Hương and studied to my university from Vietnam. I am honored to present our research title User Classification E-commerce Platform Emerging by Apple. This study was conducted by me and my lecturer Nguyễn Thị Hội. To give you a clear overview, my presentation is organized in six main sessions. I will start with the introduction and related words. Then I will move on to comparison with extending model before grappling with the conclusion and reference. Moving to the introduction, e-commerce had become a core primer of the digital economy to stay competitive with it. Increasingly adapt marketing to a personalized consumer experience. Globally, marketing is the foundation of model recommender system focused on integration, diverse data source, and advanced model like deep learning to solve problems like the gold star in Vietnam. When ship fuel is attracting growing attention and advanced marketing drive system are still under our research aim to price this gap by proposing a model that improve accuracy during marketing authenticism, uh, securing related cost reason research gathering focus to main first measuring correlation through user profile and product description. Second, measuring correlation through product feature and user behavior. Our sub pro probable a model with improved acquisition my system methods to evaluate model precision more actively. Now let's look at our probable model. Our research workflow flow struct five-step process as so in future one. It begins with data collect from e-commerce platform, then with performance proper data processing to clean and normalize data. Next is data set structure and label, followed by machine learning training using various algorithms. Finally, this system generates personalized product recommendation. Uh, in uh, in our experimental scenarios, we use etching data from tiki.vn. After processing, we dataset of 8,000 documents from which 6 samples were selected from experiment. We use a 10 fold cross validation structure in ISO robust reason. We for popular algorithm support vector machine examples canis napo and nocetic regression. This the performance with evaluate using two main metric uh, precision and F1 score. A very important part of our model is the data processing step. So here in future two, we build a process that include data clean chaining emoji to keep Simon means and label Simon. We also use Forbes to collect features from Vietnamese tech. Finally, the product were divided into 11 group such as như là kitchen, books, and future. On this side, future 3 so workflow creation from processing tech highlight common like product, quantity, and delivery. Algorithm so that the expo algorithm clear provides the performance is brought by logistic reason, sport vector machine, and finally key generous enable as you can see in future for experiments superior mental big screen precision and apps on score commerce category. We also compare our model with previous study as shown in the table. Our XGBoost model achieved a precision of 0.99, which has a reason report in several hours. This confirms that the radiation pulse and integration of system future expected improve predictive accuracy in e-commerce setting. To conclusion, our research has achieved survey key reason we successful attribute the accrue for machine author on the e-commerce data. We export as the most experimental model for this task. Our overhead improve product rating, precision, and address data. In the future, internet sports, personalized and personalized statistic will be key to successful growth in data marketplace. Thank you very much for your attention.
Thank you so much, ma'am, for your presentation. Do we have any questions? I guess there are no questions. Thank you so much, ma'am, for your presentation. I would now like to call upon Sabit Rahman sir to present his paper titled Potholes, Cracks, and Open Manhole Detection using CBAM YOLO V8 and GPS coordinate extraction via OCR for location mapping and automated alerts. Sir, you may start presenting now.
Okay, can you hear me now?
Yes, you're audible, sir.
Okay. Okay, so can you see my screen now?
Yes, sir, it's visible. You may start.
All right, so thank you everyone and ICTIS for the opportunity. I'm Sabit Rahman, the presenter and the first author of the paper titled Pothole Cracks and Open Manhole Detection using CBAM YOLO V8 and GPS coordinate extraction via OCR for location mapping and automated alerts. So my paper ID is 736. Now into introduction. So what is our project about? So it is about a multi-class detection using deep learning method and address different kind of road related issues. So why you use deep learning? We use deep learning because it can work on big data, also can learn features automatically, also versatile architecture. We have different kind of architectures, models, and everything. Also have high accuracy and also have end-to-end learning. So what is our aim? We have 4 main aims or objectives. So detecting road hazards from lives, videos, and images, capturing the exact location of those defects, then update on a map and notify the authorities to see where they have to go to fix them. Now, to talk about our motivation, here is a line that the unbearable suffering of bad roads. So like this kind of scenarios are very common in our country. To solve it, we have to do something using computer science. So we choose to detect 3 common road hazards Those are pothole, crack, and open manhole. Now, we have faced a lot of challenges. For example, we had limited data because I have to search for a lot of data sets, but there is no data where we can find all three of these classes simultaneously. So we had to collect and gather those data sets, also synchronize them. We have to annotate them, also need to ensure that it works across all kind of models. Also map integration. We had to do a lot of experimentation on this part because we didn't know how to integrate or get the exact location of those road hazards and get the exact location and alert the authorities. So we have reviewed a lot of literatures to address our issues. And in most of them, what they do is one class detection, and it is high. The accuracy is high. Also, some of the models are very slow. Some of them are have high accuracy, but it doesn't work on live videos. So they also experiment on different kind of data sets. So what we did, we actually created our own data sets, as we did not have data, like all sort of data for detecting road hazards. So we collected data from Kaggle, Google, other sources. Like we actually take real pictures using our phones and collected the data, then annotated using bounding box annotation and curated data sets. And we also uploaded that on Kaggle, as if for now we have 1,800 plus downloads. Now about our model analysis. So while experimenting, we came to know about a module called SEBAM. So SEBAM is Convolutional Block Attention Module. So we decided to use it after our first convolutional layer, because the first convolutional layer is extremely important for us because it extracts the feature. But the problem is we don't have any refined feature after that. The remaining background layer only refine them using the same method, but we have to filter them to get the precise features that can be used in later on. So what we did after the first layer, we add a SEBAM module. And how SEBAM work. To understand SEBAM, we have to know CAM. CAM also is being used in many detection module. Also SAM. So this is a combination of SAM and CAM. So CAM actually use both max pool, average pool, using multi-layer perceptron, and also use element-wise summation and a segment fashion to get channel attention. Using the same channel attention, we get defined feature, and defined feature also get also we apply max pool and average pool again, use another convolutional layer, and also apply segment function to get spatial attention. So this is how it exactly work. As you can see, we have input feature, we have channel attention module, and here we have MLP and a spatial attention module. Again, we MLP it, then we get defined feature and put it into the rest of the convolutional layers. Now we use the methodology. We have 6 phases. First, the data sets. We have already discussed about it. Like we collected it. We also also for using on different models. For example, first order CNN and Retina, we actually converted the annotation into COCO JSON format. We applied heavy augmentation. We applied rotation, flip, noise, brightness, and contrast adjustment because we had to ensure that our model works in different environment. For YOLO, we did not have to do any normalization, but for first-order CNN and Retina, we had to use mean STD normalization. So then we split the data sets. So during the model design and training, we use some hyperparameters like learning rate, epochs, and weight decay, optimizing type, and other sort of parameters to make to ensure that our model doesn't overfit. We build the models and also evaluated them for comparison in the 4th phase. So after that, we also had test images with coordinates, GPS coordinates like longitude and latitude embedded on the screen or videos images. Then we extracted them using a extraction called OCR. OCR is optical character recognition. What it does is it gets the text from videos and also images. So after using that, we actually saved it on a GPS on a map and showed it to people. Like we can visualize it, like we can see where those defections are. Also, we had a software phase where we created a software to demonstrate that our idea can be implemented into a real world. So this is our comparison. As you can see, we use Retina, Net, Faster CNN, Uliviate, and Sebam Uliviate achieved the highest result. Its MAP is 82% and like 4% boost from the base model. Also higher recall rate. And also during the training, as you can see, other model actually stopped learning at all. But our Uliviate and Sebam Uliviate actually learned a lot during the training session. So this is our MAP. So for pothole, we got 72%, which is lower, and we are still working on to improve it. Cracks, 81%, open manhole, 93%, overall 82%. So we have recall confidence curve at 91%. Now, this is the results on images, our test images. We have generated this using AI with multi-classes. And to see like does our model works on like all type of classes at the same time. So it actually did pretty good. And also here is another scenario. If you can see, like here we have a partially open manhole and my model actually detected it properly. Also, we have good images, some good images where we do not have any road defects and it did not detect any of them. Now, this is on a
Excuse me,
video.
sir.
Yes.
You have 1 more minute to conclude your
Okay.
presentation.
All right. So this is on a video with embedded latitude and longitude. As you can see in the terminal output, we have detected open manhole also with the latitude and longitude. So this is our software where we created an upload system where we can upload videos. Also have a live camera where we detected a manhole with latitude and longitude at the same time. So it works perfectly on our website as well. So this is the workflow of our software system where we will detect the latitude and longitude at the same time, then put all of them into a DB database, then just update the map. So this is very simple here. So our expected outcome is enhanced road safety, optimized maintenance effort, and update it on a map, real-time detection, and community-driven reporting. So thank you, everyone.
Thank you so much, sir, for your presentation. Do we have any questions? Okay, sir. I guess we have no questions. Thank you so much for your presentation. I'd like to call upon our next presenter, Neha Agrawal ma'am, to present her paper titled Enhanced Object Detection Using Meta-Heuristic Feature Selection in Deep Learning. Ma'am, you may start presenting.
Give me a minute, ma'am. Yeah. Is my screen visible to everyone?
Yes, ma'am, it's visible. You can
Okay.
start presenting.
Okay, ma'am. Good afternoon, everyone. Good afternoon, judges. My title of my paper is Object Detection Using Meta-Heuristic Feature Selection in Deep Learning. So I'll be first talking about the problem. My problem statement is that object detection is a critical task in diverse domains such as autonomous driving, security, and medical imaging. There are various applications of object detection, but achieving high accuracy in every situation is a difficult task, and sometimes we have problem of about like high dimensional feature representations that increase our computational costs. Sometimes the problem could be noise, occlusions, and light variations in the data, which is not which affects the accuracy of our algorithm. And the conventional feature selection methods, which are basically they can stop at wherever the local minima is, found out. So we in that case also we are not able to get the exact or the proper exact result. So our approach is using a meta-heuristic solution, meta-heuristic algorithm, a combination of meta-heuristic algorithm for feature selection to improve accuracy and reduce the complexity of object detection. So the research objective, my objective of my research is to implement a meta-heuristic algorithm for feature selection, enhance and using that meta-heuristic object detection algorithm, feature selection algorithm, we are basically trying to reduce the accuracy, increase the accuracy of our object detection by eliminating redundant features, by eliminating informative, irrelevant features, and ensuring the deep learning model focuses on the most discriminative or informative features only. Also reducing the computational cost by reducing the computational complexity, the high dimensional data to a very, almost 90% we are reducing. So by reducing to till that level, we can reduce the computational cost and training time. And then we are also evaluating our proposed approach with conventional feature selection methods and comparing the previous algorithms. This is the related work. There are various algorithms like genetic algorithm, particle PSO, particle swarm optimization. This slide is about the related work in this field only, where there are various algorithms used already. This is our algorithm that we are using. It is a hybrid approach from which is enhanced gray wolf optimizer and enhanced firefly algorithm. It is a combination of both. And it is employed as a feature selection algorithm in the basic pipeline of accuracy calculation, where CNN here, like CNN is used. If we see the slide, after data processing step, CNN is used for feature extraction. After CNN is used for feature extraction, but at this place we are getting, almost billions of features. That those features can be reduced using this hybrid EGWO and EFA algorithm. The algorithm now the from billions we are reducing the feature set to till thousands, almost 90% if we see the results. And by reducing that dimension of to a much greater extent, we are then evaluating the accuracy by reducing the computational cost, the time the algorithm was taking, and everything. Right. So what this algorithm, hybrid algorithm, is based on, it is a combination of two algorithms, enhanced gray wolf and enhanced firefly algorithm, where we initialize our population. Like, what do we mean by population here? Our population is the feature subset. Like, if we got supposed 10 features from CNN, so we out of those 10 features we will select we'll take a vector of 1 zeros, for example, and if initially that will be a random vector, and then we'll take the walls and the fireflies will be representing a feature subset, multiple feature subsets. Then we are calculating the fitness of each solution, which is the gray wall for firefly in our case. And then based on the fitness of the algorithm, fitness of the gray wolf solution or firefly solution, we are calculating, we are designating them alpha, beta, or delta. Alpha is the best one, and beta after that, delta after that. Then also initializing the attraction mechanisms for fireflies based on their brightness. Actually, firefly algorithm is based on the local refinement, which adds local intelligence to global search. And whereas walls are basically meant for global search, yes, strong global search and for fast convergence. So it is a combination. In the iteration loop, we can see there are two, we are updating the walls position as well, and we are updating the fireflies position as well. And then we are using the cross communication, that walls are getting affected, but the wolves are influenced by firefly positions. It is not wolf is not only updating its position according to global search space or gray wolf algorithm. It is also updating its position based on the Firefly solution, Firefly algorithm, which is also focusing on local intelligence. So we may not skip local optima in that case. Then also we are evaluating the fitness of our algorithm with updated solutions, ranking the and updating alpha beta data again, and updating Firefly positions again till our convergence criteria is met, which is either of two maximum iteration or until there are like changes, minimum k iterations are similar. So this is how we are getting our optimal subset of features. And this is our experimental setup where this is the entire pipeline where, in this step, actually evaluating fitness of each solution, we need the accuracy as well. So that accuracy is first of all calculated using SVM, and then but that is there in the loop. And we are applying feature selection algorithm. And then for the accuracy calculation, again, we are applying SVM. This is pre-feature selection stages. Before CNN, we are using actually a combination of SIFT and SURF and CNN to get the extracted features. And these are our results of feature selection, where uh, we have used two data sets, Pascal Vogue data set and brain tumor data set. There are if you can see the slide, there are total number of feature extracted using using CNN is around 5.5 billion, and without applying feature selection. But if we apply enhanced gray wolf algorithm and a combination of gray wolf optimize, actually this is the combination. If we apply the hybrid one, then the number of features we are getting is 49,852. Similarly, and we have compared our results with the remaining algorithms as well, where we are applying remaining algorithms like Firefly, Real Hard, Cuckoo Search. There are various algorithms, and we are comparing this with our result. Then we are also applying the same algorithm on brain tumor data set, which we have
Excuse me, ma'am.
taken from
You have one more minute left to
RoboFlow.
conclude your
And
presentation.
there are also total number of features are many more. Okay, ma'am. So we have many features, and we are only left with almost 90% or 90% less number of features. In this case, also with brain tumor dataset, we are only left with 1,10,996 features. So using this algorithm, we are actually optimizing. We are reducing the features till to a great extent. And so that the execution, we are also comparing the execution time taken and the accuracy and the training time taken, training loss, validation loss, precision recall, in everything, every parameter is compared when we are not using feature selection, and when we are using feature selection, the time has reduced to a much more greater extent. We can see the results in hybrid gray wolf and Firefly algorithm. Now the time taken is very small, though the accuracy has improved to a small extent, but yes, the competition and everything has reduced to a greater extent. So these are our results. These are the graphical representation of the same results almost. And this is our conclusion based on this study proposed a hybrid object detection framework combining enhanced gray wolf optimizer and Firefly algorithm. And we have demonstrated improved algorithms and improved precision and accuracy in both the data sets. We have reduced computational load, making the approach suitable for resource constraints environments. And this is our future direction. We can replace SVM with CNN for more end-to-end learning, and we are like for improving the accuracy further, the time further. Optimization for we can work on edge deployment, edge devices which have less number of low resources. we can integrate attention mechanisms or transformer-based models to the same study. And our goal will be to advance intelligent, adaptive, and scalable object detection solutions for diverse real-world conditions. Thank you so much.
Thank you so much, ma'am, for your presentation. Do we have any questions?
Gayatri, I just have one question. Neha ma'am, can you mention what is the size of the data sets that you have used for experimentation?
Yes, sir. In almost brain tumor data set, there were around 9,900, 9,900 images, and in case of Pascal work, it was around 11,530. 530 images. The both are benchmark almost Pascal worked 2020 2012 I took, and it has it is a benchmark data set. It has 20 classes categories, and in case of brain tumor data set, it is not a bench. Almost we can say RoboFlow. I have taken it from RoboFlow. I have taken both the data sets from RoboFlow, and there are many like a Kaggle. It is another repository, and I've taken both the data sets from there.
And any challenges while storing such a large number
Yes,
of.
sir. Yes, sir. When we run it using collaboratory, and yeah, there are many number of iterations. कई बार सर ये होता है कि if we run it overnight, algorithm stops in between, and then we need to restart again. So there are problems faced. I used it, Google Colab for the same thing for running.
Okay, all right.
Thank you so much.
Gayatri,
Thank you
over.
so much, ma'am. Thank you so much, sir. Thank you, ma'am, for your presentation. Now I'd like to call upon Chetrishri, ma'am, to present her research paper. Ma'am, you may start presenting.
One minute, ma'am.
Yes, ma'am, sure.
Ma'am, shall I use, rather than the PPT, can I go through the PDF, ma'am? Because it is unsupported format is here, ma'am.
Sorry?
Shall I go
Can
through
you
the
please?
PDF,
Yes, ma'am.
ma'am?
Go.
PDF?
No problem, ma'am. Go ahead. Go ahead.
No problem, ma'am. You can share the PDF.
Yes, ma'am. Yes, today I'm going to present a paper on secure medical image communication in post-quantum era, development and validation of a.
Ma'am, there is echo at your end. Can you please check?
Yes, sir. Ma'am, now this is audible, sir?
Yes, ma'am.
Hello.
That's okay. Yeah. Please continue.
Today I'm going to present a paper on secure medical image communication in post-quantum era, development and validation of a comprehensive dataset for a cryptographic protocol testing. And major objective of this paper is to develop a covert communication algorithm based on a quantum cryptographic to secure the data, and also to develop the data security techniques with least computational complexity, and to compare the effectiveness of a proposed algorithms in terms of a security, quantity, or for secret information, etc., with existing quantum computing techniques, to suggest the best technique out of the proposed technique for a different applications. And majorly, each and every day, we are producing large quantity of data from different aspects. But major thing is to how we are going to protect the data, and also how we are going to maintain the data in the healthcare department, to maintain the data, the patient's data confidentiality, developing MedSecure PQ in healthcare communication system. And this data comprises of CT scans, MRI scans, X-rays, and ultrasound data of 15,847 medical images over a 18-month of a period. We have conducted several experiments with the 5 NIST approved, National Standard of Institute Technology approved post-quantum cryptographic algorithms. Those algorithms such as Crystal Kyber, Crystal Dilithium, Falcon, Spinix Plus, and Classic McClay to demonstrate on encryption latency, decryption efficiency, and communication overhead. Majorly, the Crystal Kyber achieves optimal performance of 99.97% of a data integrity for processing 2 MB of a medical image within a 2.3 milliseconds average encryption time. In the medical imaging generations, approximately 2.5 exabytes of a data annually with 85% of a radiological images in healthcare data storage. The National Institute of Standard and Technology approved post-quantum cryptographic algorithm to fulfill the need for a post-quantum resistant security measures. Major limitations of this PQC implementation is to large in file size, require real-time processing, GDPR framework, existing medical image datasets focus on the machine learning applications rather than the cryptographic protocol. Similarly, post-quantum cryptographic evolution for a generic data, it fails to capture the complexity and diversity of a medical images. And also had some literature survey researched on the few points. Bernstein and Large demonstrated the current RSA ECC implementation with the quantum computers with 4,000 plus logical qubits threshold within 10 to 15 years. It's vulnerable due to long period. And Mudsins also evaluated PQC with electronic health record, but mainly focused on the text-based raw data rather than the image. Chen and Rodriguez also analyzed network latency issues in PQC, but they utilized synthetic data rather than the authentic medical images. Kumar identified critical vulnerability in existing medical imaging, particularly in DICOM protocols. Thomson and Lee demonstrates that quantum algorithms comprises of medical images watermarking schemes within hours rather than the centuries required for a classical attacks. And majorly, this paper consists of a methodologies of image acquisition. Here, I have took 4,231 images of a CT scans and 3,892 images of a MRI scans and 4,564 images of a digital radiography, 3,160 images of a ultrasound. And this file size around 256 KB to 8.5 MB. Compression ratio is of 2000 lossless JPEG. Acquisition timestamp, modality specific parameters, cryptographic testing vectors. Majorly, the validation and quality control, we eliminated the corrupting files, the duplicate images, and also final data set comprises of, we got 15,847 images with complete metadata records. Post-quantum cryptographic algorithm selection. Out 5 NIST approved algorithm. Those are Crystal Kyber, Crystal Dilithium, Falcon, Spinix Plus, and Classic McClay. Crystal Kyber uses lattice-based key encapsulation mechanism. Crystal Dilithium uses lattice-based digital signature scheme. Falcon uses lattice-based compact signature. Spinix Plus is hash-based signature scheme, and Classic McClay code-based key encapsulation. Majorly for this experimentation, we required primary server, Dell, and network environment for WAN latency up to 5 to 50 milliseconds. Storage is around over 10 GB throughput. Operating system is Ubuntu or Linux. And we are performing some, we are testing some parameters and measuring those things are encryption, decryption, latency, key generation time, memory utilization, network communication overhead, data integrity verification. Along with that, we also performing following things, that is key generation latency, encryption time per megabits, decryption time per megabits, end-to-end communication latency. And also we use as resource utilizations are peak memory utilization in megabits, CPU utilization percentage, network bandwidth overhead, and security metrics are data integrity verification success rate, authentication failure detection rate. And this is the table represents the results and analysis. First table represents the data set along with the modalities. Here we are majorly taken 4 images from backgrounds, that is CT scan, MRI scan, X-rays, ultrasounds, among which CT scans takes the sizes among the 2.4, compression ratio is 3:2:1, MRI scans takes 3.1, and ratio is 2:8:1. These are all the different modalities of taken from the different images. And this is post-quantum cryptographic performance, among which encryption performance comparison. We are comparing following 5 algorithms, among which Crystal Kyber takes the success rate of 99.97. Along with that, Spinix Plus also takes the 99.98% is more than the Crystal Kyber, but average encryption time is 9.95 Crystal Kyber taken, but Spinix Plus is 45.67. Here takes large quantity of a time to process those images. So for that, we can easily conclude that Crystal Kyber takes the 99.97 success rate, among which it takes only a few minutes, milliseconds of a time, that is 0.95. And this third table represents the decryption performance analysis. Decryption performance analysis. Here, comparing these 5 algorithms, Crystal Kyber is excellent. Along with that, Falcon Spinix Plus is also excellent. But here, average decryption time is Crystal Kyber takes 0.87, Spinix Plus is 0.34. But among which that, Spinix Plus demonstrated the experimental decryption performance due to the simplified hash verification process, while Classic McLean exhibited poor memory efficiency, limiting scalability, high throughput through the medical image environment. And the fourth table represents the network communication overhead. In this network communication overhead, this Crystal Kyber bandwidth takes plus 12. Along with that, key size is 1.5, but Spinix is plus 6 with the key size is 0.6. So Falcon and
Excuse me,
Spinix.
ma'am.
Yes,
You
ma'am.
have 1 more minute to conclude your presentation.
Yes, ma'am. Yes, ma'am. So this so that we can easily conclude that the Crystal Kyber takes the only 99.97% of a processing the 2.3 milliseconds of average encryption time among the 2 MB medical images. So it takes 99.97 data integrity. So these are all the future and the limitations of my paper, that is dataset scope, network diversity, and quantum threat timeline. So easily we can conclude that after rigorous experimentation with the 5 NST standardized PQC algorithms, we demonstrate that quantum resistant security can be achieved with minimal performance impact in a healthcare environment. The MedSecure PQ dataset provides the researchers with standardized benchmarks for developing and evaluating quantum resistant medical images. And these are all the references I referred. Thank you.
Thank you so much, ma'am, for your presentation. Do we have any questions?
No questions from my side.
Okay. So we have no questions. Thank you so much, ma'am. I would now like to call upon Pankaj Chandri sir to present his paper titled Phishing in the Era of Generative Artificial Intelligence, a systematic survey of attack models, detection strategies, and explainability. Sir, you may start presenting.
ನಾನು ಸ್ಟಾಪ್ ಮಾಡಿದೆ ಶೇರ್ ಮಾಡೋದು.
Am I audible, madam?
Yes, sir, you're audible.
Okay. Can I share my screen?
Yes, you can.
Is it visible? Ma'am, is it visible?
Yes, sir,
Yes,
it's
sir, it's
visible.
visible.
Please
Okay,
go
You
on.
may start.
okay, thank you. Good afternoon to one and all. Today I'm going to present our work on phishing in the era of generative AI, attack models, detection and explainability. So on behalf of my primary author, I am going to present. This is the outline of my project, Introduction, Evaluation of Phishing, Generative AI-based attack models, detection techniques, explainable AI architecture, dataset and tools, challenges, and lastly we can say uh, conclusion. So basically, nowadays we are going to deal with phishing attacks. How we've seen a significant rise in significant years, in recent years, due to some advancement in technology. And at the same time, we have generative AI, which enables attackers to create highly realistic and convincing contents at a proper scale also. So basically, in this ones, we are going to consider some techniques such as LLM, GAN, and you can say again deepfake. So all these are we are going to consider as a commonly used in modern attacks. Means all the attackers nowadays are going to use LLM, GNN, and or you can say deepfake models also. And as a result of our traditional detection methods are becoming less effective and requires more and more improvements. If we are going to consider if we are interested to go with our traditional one, so definitely in that one we require what you can say major improvement. Okay, and nowadays in AI we have many more options just like LLM, Janan, you can say defect attack also. So basically in this one, that is evaluation of your phishing, we can consider from simple emails to targeted one, peer phishing and dwelling, social media and mobile phishing, and multimodal phishing growth also. So basically your phishing has evolved from single email based scam to highly targeted and personalized attacks. In this one, initially your attackers are going to use some generic message, but now they are use some techniques like spear phishing and whaling also. Again we can consider we have what social media and mobile platforms have also become common channels for phishing. So additionally, modern attacks often involve multimedia elements, making them more convincing and difficult to detect. So basically, your attacker is going to use all these techniques. It means normally they are going to mail something. Yeah, we by considering contents of that mail, we can say yes, this contents looks like a original one, or you can say important one. So basically, we are going to open that contents, and in that mail we have some links. Okay, and we are going to click on that link. So once we are going to click on that link, so definitely we are going to face what many more options. So we are going to suffer all these things like that one you can consider. So next we can consider generative AI attack models. Yeah, first one we can consider LLM, second one we can consider deepfake voice and video attacks, last one we can consider is going to work phishing as a service, and lastly adaptive and reinforcement based attacks. So basically your generative AI has introduced some new and advanced phishing attacks models. Attackers are going to use large LLM to generate realistic phishing emails that are difficult to distinguish from genuine one. With the help of deepfake technology allows in personalization through voice and video, and phishing as a service platform make these attacks widely accessible while AI-driven system continuously adapt to improve their success rate. Right now, so creating any attack nowadays is very simple because of this LLM, deepfake voice and video attack, and phishing as a service. With the help of that one, we can create any attack, we can broadcast it, and definitely users are going to suffer for the same. Yeah, machine learning detections. So yeah, in that one we can consider future based ML. Some common algorithms we can use SVM, random forest, naive bias. Again we are going to use some URL, email, or you can say metadata features, and we have some limitations for this machine learning detection, and that limitations we are going to consider as a poor adaptability. So basically your traditional machine learning techniques such as SVM, random forest, and naive bias are widely used for phishing detection. These models rely on features like URL, email contents, and metadata. They are efficient and easy to implement, but definitely they have some limitations. So especially they struggle to adopt to new and evolving phishing techniques, reducing their effectiveness over time. So basically in this one, we are going to consider some data set. So just imagine I have some data set. That data set consists of 20 features. Okay, so just consider attacker is going to use one new additional feature, and that additional feature is not part of my 20 features. So definitely that time my system is not going to detect that one. In simple case, we can say my system is going to fail. If any features which is new but that is present in my data set, so in that case definitely my system is going to work properly, but for new features my system is not going to work properly. So like that one we can consider is nothing but the limitation of your traditional one, that is SVM, RF, or any machine learning, you can say classifier. Means that algorithm or the classifier is not going to add up new feature. So deep learning detection. So yeah, again we can consider some well-known or commonly used algorithms just like CNN, RNN, LSTM, and transformer, but improves semantic understanding. Yeah, definitely as compared to your ML, we are going to use DL for a high accuracy but with low interpretability. So your deep learning approaches use advanced models just like your CNN, RNN, LSTM, and transformer for phishing detection. Models such as BERT provides better semantic understanding of textual data. These methods achieve higher accuracy by capturing complex patterns. However, one major drawback is that they lack interpretability, making it very difficult to understand their decision-making process. In simple words, we can say as compared to your machine learning classifier, your deep learning classifiers are going to work, and definitely your deep learning classifiers are going to provide more accuracy also. Okay, then multimodal detections. So basically in this one we are going to combine multiple types of data, uh, including your text, images, audio, and video, and definitely we are interested to improve our accuracy. Yeah, we are interested to detect that something, we are interested to classify something, or we are interested to consider anything while dealing with your MLR DL. So definitely we are going to talk about what accuracy, and definitely we are going to expect more accuracy. Yeah, again, we can say it uses fusion techniques such as early and late fusion to integrate information. This approach is more robust and effective against your modern phishing attacks, and definitely by analyzing multiple data sources, it significantly enhances over detection performance. Yeah, your explainable AI is going to play a major role in this one. With the help of that one, we are going to improve transparency and text trust. Yeah, commonly used techniques in this explainable AI is Lime and Shaft. So explainable AI plays a crucial role in improving the transparency of AI model. Techniques like Lime and Shaft help explain how models make decision. Visualization methods such as graph, cam, and attention map provides deeper insights, and this increases trust among users and helps security analysts better understand, validate the results. So normally we are going to perform something, we will get some result. If
Excuse
someone,
me, sir. You
yeah,
have 1 more minute to conclude your presentation.
okay. So my proposed architecture, I am going to consider as a text, URL, and multimedia as an input. After that, I am going to extract some features. Yeah, I am going to use MLDL classification. After that, I have my XAI based explanation, and lastly, I am going to alert or mitigation. So that one I can say is what my output. My architecture looks like this one. Yeah, data sets. Some data sets are available in Run, UCI, Kaggle, fish tanks. So we can consider anything, any one data set. Some tools are available: Scikit-learn, TensorFlow, Hugging Face, just Sharp and Line, and Virus Tutorial and Selenium also we can use. Yeah. So definitely while implementing same systems, we have many more limitations. We are not going to add off that one. So definitely we are going to face some challenges also. So detecting zero-day attacks remains a major issue. Adversarial attacks can manipulate models and reduce accuracy. your priori concerns arise when handling sensitive user data. Additionally, there is always a trade of model accuracy and explainability which needs careful consideration. So definitely we are going to face all these challenges. Lastly, I am going to conclude my presentation. So in conclusion, generative AI has significantly increased the sophistication of phishing attacks. Your traditional detection methods are no longer sufficient to handle these threats, and multimodal detection techniques offer improved performance while external AI enhances trust and transparency. So, in future research should focus on real-time detection systems that are both efficient and privacy aware. Yeah, with the help of your data set, you can track anything, but major challenge we can face, or we can say we have a major improvement. So for that one, we can consider as a future work, and in our future works, definitely you need to try your design or develop system on real-time data set. Yeah. Thank you for your attention. I hope this presentation provides useful insights into modern phishing attacks and detection method. I would be happy to answer any questions you may have.
Okay, I have one question about this topic. What are the main limitations of your current approach?
So major limitations is what, sir? We can try for any available data set. So in that one, we know each and every feature. If any new feature came, so definitely that one is difficult. Means our system is not going to add off that new feature. So that adaptability we can consider as a major limitation.
Thank you.
Yeah.
Thank you very much.
Thank you, sir.
Thank you so much, sir. Pankaj, sir, I believe you have one more
Yes,
presentation
yes, ma'am.
for the
Yes,
session.
yes. Just give me 1 minute, madam. Yeah. Is it visible?
Yes, sir, it's visible.
Yeah.
You can start.
Yeah. Good afternoon to one and all. Myself, Dr. Pankaj Chandre, and I'm going to present a paper titled Towards Interpretable Edge Intelligence, Explainable AI in Resource Constrained IoT Devices. So, Mandar Mokashi, Sonali Bote, Vishal Naikwadi, Atul Kulkarni, and Dr. Parikshit Malle, sir. All these are my co-authors, and on behalf of my primary author, that is Mandar Mokashi, sir, I'm going to present this work. So this is outline of my project, my presentation. I'm going to start with introduction, edge intelligence, and lastly, I'm going to cover some challenges and conclusion also. So basically, while dealing with this topic, definitely we are going to consider the shift from cloud to edge AI enables faster processing by bringing computation closer to data resources by allowing real-time decision making in critical application. Again, we can say this decentralization introduces some challenges which are related to transparency, trust, and accountability. So as a model, we are going to operate in less control environment. Again, your interpretable AI becomes essential to understand how decisions are made, especially in safety critical domain. Again, it's going to help stakeholders validate model behavior, detect some biases, and ensure compliance with some ethical standards. And lastly, explainability builds your confidence and support reliable deployment of edge AI system. So basically, in that one, we are going to focus on what you can say edge intelligence. So processing directly at IoT devices enables faster data handling and support real-time responses without relying heavily on centralized cloud systems. This approach significantly reduces latency and enhances privacy as the sensitive data remains closer to its source. IoT devices face strict resource constraints, including some limited CPU power, memory capacity, and energy availability. And these limitations make it challenging to deploy complex AI model efficiently. Therefore, we are going to introduce lightweight and optimized algorithm as a essential part for effective edge intelligence. So explainable AI concept can be categorized into instance methods where models are innately interpretable and post-hoc techniques which provides explanation after model predictions. Additionally, explanation can be local or global, and in edge environment, selecting the right type of explanation is crucial due to limited computational resources. Resource awareness explainable AI aims to balance interpretability with efficiency and at the same time is going to ensure explanations are both meaningful and lightweight. So this is essential for defining trustworthy AI on constrained IoT edge devices. So we are going to follow some taxonomy. Model intrinsic method focuses on usually inherently interpretable models that provides explanation as part of their structure, making them suitable for resource constrained environment. Your lightweight post-hoc methods, on the other hand, can generate explanation after prediction while minimizing computational overhead. And in edge and IoT system, deployment aware explainability is crucial as it considers device limitations, latency requirement, and energy efficiency. So selecting appropriate XAI techniques ensure that your explanation should remain practical without degrading system performance. So this balance is essential for achieving efficient and trustworthy AI deployment at the edge. We have many more choices, but definitely we have to select particular one, and definitely that particular one is going to satisfy our all requirement. So we have designed some architecture that consists of some explanatory by design, hierarchical explanation control, and lastly, adaptive and resource aware uh, system. So our architecture is going to start with some sensors and actuators generating real-time data. Means with the help of that one, we are going to generate that data, and that generated data we are going to provide as a input to our system for the purpose of what processing. So this processing is means is processed locally on a resource constrained edge IoT devices. After that, a roll of lightweight AI models performs inference while an explainability by design layer ensures interpretable outputs. On device, we have some explainable engines is going to generate some quick how cost insights for immediate decisions. The edge layer means redefines explanation by monitoring some contents, detecting some anomalies, and adaptive explanation granularity. So secure aggregation and cloud layer is going to handle all these deeper analysis, then long-term trades and policy compliance also. So finally, we can consider trustworthy and understandable explanations are delivered to human stakeholders for informed decision making. So lastly, we are going to provide some decision to the stakeholders, or you can say uh, users as a output. So basically in this one, that is resource awareness, we have some techniques. Yes, lightweight approximation, energy aware explanation, and lastly we can say aware latency aware execution. So lightweight approximation enables simplified explanation techniques that reduce computational overhead while retaining essential interpretability. Your energy aware explanation prioritize minimal power consumption, making them suitable for battery operated and edge and IoT devices. Your latency aware execution ensures that explanations are generated within strict time constraint for real-time decision making, and combination of all these approaches optimize the trade-off between explainability and system efficiency. So simply we can say this is a crucial for deploying practical and scalable explainable AI solution in resource constrained environment. Streaming and adaptive explainable AI. With the help of that one, we are going to handle real-time data streams, adapt to explanation generation, and is going to conceptual brief handling. So basically, the system efficiently handles real-time data stream by continuously processing incoming IoT data at the edge. Your adaptive explainable explanation generation is going to adjust the level and type of explanations based on context, user needs, and user constraints. Is going to ensure that explanation remains relevant even as data patterns change. So concept drift handling enables the models to detect and adapt to evolving data distribution over time, and this maintains both prediction accuracy and the reliability of explanation in dynamic environment. Security and privacy. So explainable explanation leakage risk arise when generated explanation unintentionally reveals sensitive data or model internals, potentially compromising privacy and security. Your adversarial manipulation involves attackers exploiting explainable mechanism to mislead users or reverse engineer the model, and these threats are especially critical in distributed edge environment. Your federated and secure XAI approaches address these issues by enabling collaborative learning without sharing the data while incorporating privacy preserving techniques, and this ensures that explanation remains trustworthy, secure, and compliant with
Excuse me, sir,
data.
you have 1 more minute left to conclude your presentation.
Okay. Yeah, evaluation matrix. Definitely, we are going to consider accuracy, latency, and energy, user trust, and interoperability. Yeah, definitely, we have some application. We can use same system in health for healthcare monitoring. We can use same system in industrial IoT. We can use same for smart cities. We can use for environmental monitoring, and many more applications we can consider. So definitely, we are going to face some challenges. First challenge is what? Resource data, yeah, sorry, resource constraint, lack of benchmark, security threats, and human-centric evolution. Yeah, lastly, I can conclude. Nowadays, your edge explainable AI is essential. Definitely, it needs explainability by design, and definitely in future we are going to consider some adaptive and secure system. So, thank you.
Do we have any questions?
No questions from my side.
Okay. Thank you so much, sir, for your presentation. And with that, all our presentations for today have come to an end. So I would like to move towards the closing remarks. I would like to sincerely thank our authors for their excellent presentations and contribution in this session. Also, all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. And we'll be happy to have you in the 12th version in 2027 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would like to thank our session chairs, Dr. Esteban Ricardo Gomez Torres and Professor Nathan Sacre for chairing this session. Here is a token of appreciation to the chairs on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your presence, sir.
Thank you very much for this opportunity to share with you.
Thank you,
Yes,
Gayatri.
thank you
Thank you.
so much. Thank you so much, sir.
Hi, ma'am.
Now,
Gayatri, ma'am.
before finally ending the session, I would request you all to switch on your cameras for a quick snapshot. Can you all please on your cameras? Okay, thank you so much. We are done with this session. You all may now leave. Thank you. Stay safe and take care.
Bye-bye. Thank you very much. Good night. Take care.
Thank you,
Bye.
madam.
Thank you.